Welcome back to division of rational expressions. Today what we're going to focus on is if our rational expressions contain monomials. Now that's great because again, it's always back to vocabulary. Monomial means we're connected by multiplication, and as long as we're connected by multiplication, we could start the division process. If you look at my expression in my PowerPoint note, I have 12a to the fourth b over 25xy divided by 84ab squared over negative 10xy. So if you look, we have two fractions and we're connected by the operation division. In fraction land, division does not exist. Does everybody understand that? You're never dividing in fraction land. Your first step is always to rewrite the statement as multiplication by taking that second fraction and doing its multiplicative inverse. So the first fraction stays put, and now I'm going to flip, slang word, the second fraction. So the negative 10xy will move to the numerator, and the 84ab squared would move to the denominator. Is everybody cool with that? Great. Now we're back to the same song and dance. Multiplying fractions is no problem. Top times top, bottom times bottom. Before you start to multiply, factor first, then divide. So I know I want to multiply, but I'm not going to multiply across yet because I want to do my reducing, my dividing. Because all these expressions are monomials, they're connected by multiplication, we could just start the division process. So I take my first numerator, 12a to the fourth b, and I look closely and I say I can divide it with 84ab squared. So let's go step by step. 12 and 84, the coefficients, their greatest common factor is 12. So 12 divided by 12 is 1, 84 divided by 12 is 7. A to the fourth and a, their greatest common factor is a. So a to the fourth divided by a is a cubed. A divided by a will cancel out. I have b and b squared. Their common factor is b. So b divided by b in the numerator will cancel out. B squared divided by b will leave a b. So now I'm going to rewrite what I have. My new fraction in the numerator has a 1a cubed, which we could just write a cubed. The denominator is still 25xy. In the second fraction, I still have the numerator negative 10xy, and in the denominator now I have a 7b. All right? Now I'm going to move to the second numerator, negative 10xy, and find a term in the denominator I can factor it with, which would be the 25xy. So negative 10 and 25 have a greatest common factor of 5. So negative 10 divided by 5 would give me a negative 2. 25 divided by 5 would give me a 5. Then in the numerator I have xy, and in the denominator I have xy, and that's the same term, so we know that cancels out. So now my new fractions that I have left to multiply are a cubed over 5 times negative 2 over 7b. See how easy this is going to be to multiply now? If we go across, we'll get negative 2a cubed. If we go across in the denominator, we'll get 35b. And now that product is in lowest terms. So the rule of thumb is you have two fractions connected by division, you first rewrite your expression as multiplication, and then you go on your merry way. All right, let's go to the whiteboard and try one more example.